someone asked me this week about the similarities and differences between human languages and computer languages. So here's my take as a linguist who does some programming. First off, what is a computer language? It's essentially a system for giving commands to a computer. So these commands can be things like mathematical operations, adding or multiplying. It can be things like storing data or accessing data from memory. Or it can be things like evaluating conditionals. So if A is true, then do B. Otherwise, do C. You can think of a computer program as essentially a recipe for a computer, a set of steps for a computer to follow. And some of these are really short, some of these can be really long, but computer programs are essentially all recipes. Okay, so how are computer languages like human languages? So one similarity is the idea of compatibility between different types of languages. So here's what I mean. When we think about human languages, any idea that we can express in one human language can be expressed in any other human language. Now, some ideas might already have an existing word for them in one language, and we might need to borrow, invent, or explain that idea, borrow or invent a term for that idea, or have a longer explanation of that idea in another language. But any idea we can express in one language, we can express in the other. We find the same thing for computer languages. Any set of commands that you can write a program for in one computer language, you can write in any other computer language. This idea, when applied to computer languages, is called Turing compatibility. Now, there are certain tasks that one computer language might be a lot better for, or might be a lot worse for, but if you can do it in one computer language, you can do it in any other. Just like if you can say it in one human language, you can say it and express that same idea in any other. Now, another similarity between human languages and computer languages is that both of them have a fairly limited repertoire of kind of basic components that can be combined in an infinite number of ways. So you think about like when we think about language, we think about a really limited number of sounds, and kind of a set relatively set vocabulary, kind of a relatively, much larger but still limited set of vocabulary. But those words can be combined in an infinite number of ways to express ideas that nobody's ever expressed before, maybe that no one's ever even thought of before. We find a similar parallel in computer languages, where we've got a really limited number of keystrokes or kind of basic operators and basic commands. But within that framework, we can do an incredible amount of different operations. And there's a really huge opportunity for creativity of creating from these relatively simple building blocks. Now, a third way that human languages and computer languages are related is the idea of recursion. So when I think of recursion, the idea of recursion is one thing inside itself, inside itself, inside itself. So this would be, like if I'm thinking about a visual for recursion, I like to think of those Russian nesting dolls, where you have one little doll inside of a slightly bigger doll, inside of a slightly bigger doll, inside of a slightly bigger doll, and so you've got kind of a doll inside a doll inside a doll effect. So that's what recursion is. So here's an example, simple example from language, human language, of recursion. So I'm going to introduce an idea called a relative clause. So a relative clause in English usually begins with the word that and expresses some additional details about a noun. So for instance, we could take a noun, the mouse, and we could specify which mouse we mean. The mouse that has brown hair, or the mouse that ate the cheese. So that part, that ate the cheese, is the relative clause, and it basically creates it's basically kind of a sentence inside of that relative clause that affects the noun. Okay, so the cool thing about relative clauses is that you can put a relative clause inside another relative clause. So what could that look like? So that would be something like the cat, that's kind of our head noun, and we could say the cat that chased the mouse that ate the cheese. So you've got, which cat was it? It was the cat that chased the mouse that ate the cheese. So that's kind of our bigger relative clause. But inside that, we've got that smaller relative clause that ate the cheese. And we can stack these up. There's, in theory, no limit to how many relative clauses we can put inside each other. So this is used to great effect in the nursery rhyme, The House That Jack Built, where it goes on and on about, the girl who milked the cow, that kicked the dog, that chased the cat, that followed the mouse, that ate the cheese that was in the house that Jack built. And you just get relative clauses inside each other piling up to really, really high level. So this idea of, in theory, infinite recursion also comes up and is a really powerful tool in computer programming languages, where computer programming languages, often you write a simple set of instructions that are done again and again and again, like one inside of the other. This is a really powerful aspect of both human language and computer languages. Now, there's also some really key differences between human languages and computer languages. So the first is that human languages are really special to humans. So sometimes linguists talk about them being innate. There's a lot of different things that people potentially include in that term. But for our purposes, I just want to focus on this idea that everywhere you find humans, you find language. And whether that's communities of hearing communities that have spoken languages, if you get a community of people who are deaf, they create their own language, a sign language. And we've seen that happen a lot of times throughout history. So wherever you find humans, you find language. There's something kind of special and kind of uniquely human about language in this sense. Computer languages are really different. Computer languages are really kind of a bridge between computers and human languages. They're not really native to computers in the sense of this isn't how computers, they're not a great representation of how computers really represent and process data. And they're not really super easy for humans to learn either. They're kind of an in-between between computers and humans. So for computers, if you look at kind of inside computers, everything's represented as, fundamentally, maybe you've heard of the idea of binary. Everything's a 1 or a 0. And this is true. Everything inside a computer is either represented as a 1 or a 0. You can think of that as like a light switch being on or off, or kind of as an electrical signal being either present or absent. So inside a computer, everything is represented as a 1 or a 0. Now you can stick those 1s and 0s together to make larger numbers. So for instance, if you just have a 0 by itself, that's 1, and then a 1 represents 1. Think about our number system. When we count up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, when we run out of numbers, run out of kind of base digits, then what do? We move over to the kind of next next decimal place over. And so the same thing happens in binary. So you go 0, 1, and then after that, 1, 0. And then 1, 1. Then 1, 0, 0. So 1, 0, 0 would represent 4. 2 1s next to each other would represent 3. And we're just counting up just like we do with our numbers. Just instead of getting to 9 and then spilling over, we go from 0 to 1, and then we have to spill over. And so this is how computers represent everything. What are letters? How are letters represented? Every letter gets its own number. How are pictures represented? Well, every color has a number that's associated with it, and every pixel has a number associated with it. Even sounds are represented as numbers. You go, 1,000th of a millisecond in, and we measure the air pressure at that level, and then 2,000ths of a millisecond in, and we represent the air pressure at that level. And so sounds, videos, text files, anything you can imagine, even computer programs, everything is represented as a series of 1s and 0s. And so there's computer languages are really an in-between between human languages, which are kind of native to humans, and this kind of system of 1s and 0s that's native to computers. Computer languages, before a computer can actually really do anything with them, internally they get converted to a series of 1s and 0s. But it's a lot easier for us to write, if A, then B, than to write 0, 0, 1, 1, 0, 1, 1, 1, 0. In theory, of course, you could program a computer that way, but it's extremely hard. So that's an important difference between human languages and computer languages. So another difference is that human languages are used in a wide variety of different domains and different communication settings, and are most frequently associated with kind of communication. There's like a two-way communication, whereas computer languages are primarily a one-way communication. Computer languages are primarily used in one-way monologues, where we're giving a recipe or a set of instructions for a computer to follow. And this is really different than most interactions that I'd say most people have with language, where it's a two-way communication or conversation. Now, there are situations in which computers give us output back. Usually that's not in computer language. Sometimes it is. You can write a program that writes another program, and that's its output. But in general, computer languages are really designed for us to give instructions to a computer, not for computers to give information back to us. It's one way and kind of limited in that respect. Now, a third way that human languages are really different from computer languages are the mistake tolerances. So if you have done anything with computers, I'm sure you have encountered the idea or had the experience where you tell a computer to do something and you think that what you said is perfectly clear, but the computer misunderstands you and does something completely different than what you actually wanted it to do. Humans are thankfully much, much better at coping with mistakes. And this is really comforting for us as language learners. That you can make a lot of mistakes in human language and people can still understand you. You can get the point across that you're trying to communicate. Whereas with computer languages, even the tiniest mistake in an extremely long program can make the computer totally crash or do the exact opposite of what you wanted the computer to do. So this is really comforting and encouraging for me as a language learner, just how many mistakes you can really make and still be understood. So here's my take as a linguist for some of the key differences and similarities between human languages and computer languages. What are your thoughts? Did I miss anything? Come join us at our community Go Lingo Lab on Facebook and join the conversation. Let us know, what videos do you want to hear, and what other questions do you have about computer languages or human languages or language learning in general?